Okay, so again, what I was saying is that the raising operator A plus is equal to this prefactor, which basically makes the dimensions work out so that A dagger is dimensionless, or A plus is dimensionless, and this is equal to this A plus is equal to this constant times minus I times the momentum operator plus m omega plus the position operator x. Okay, and A minus is just equal to something very similar but with a plus sign. So it's not at all clear right now why A minus goes with the plus sign in front of IP and A plus goes with the minus sign in front of IP. But in the next lecture, this will become abundantly clear. Okay, and so now let's take the product of these two operators, or let's look at A minus A plus. Okay, so if we do this math, we have these two prefactors multiplied by each other, so we get it squared, and then we get plus IP times minus IP, which is p squared. We get m omega x squared, and now you have to do the cross terms. Okay, so you get plus IP, or you get minus IP times m omega x, and you get plus IP times m omega x. And so then what you're left, so when you factor out the minus m omega, what you get is xp minus px for the cross terms. Okay, and because they don't commute, you can't just you can't just say that's 2I m omega xp. Okay, so so we have to write it like this, and we know that this is basically the commutator of x and p, and we just showed on the previous view graph that that's equal to IH bar. Okay, and so if we use that fact, then we can write this product. If we do the factorization, this is equal to remember h bar the Hamiltonian operator is equal to 1 over 2 mp squared plus m omega x squared. So if we make that substitution here, then we get that A minus A plus is equal to 1 over h bar times the Hamiltonian operator h plus a number a half. Okay, we can rewrite this, so we can rewrite the Hamiltonian operator h now just by rewriting this equation in this form. So h is equal to, solving this equation for h, we get h bar omega times A minus A plus minus the number a half. Okay. In the same way, we can show that we can also write the Hamiltonian operator if we basically find the product A plus A minus. Okay, that's 1 over h bar times the Hamiltonian operator minus a half, and so we can write the Hamiltonian operator in this way: h bar omega A plus A minus plus a half. Okay, we also notice that the commutator of A minus and A plus is equal to 1. We could also show that the commutator of A plus A minus is equal to minus 1. Okay, so we have two new ways of writing the Schrodinger equation. Okay, we can use the product A plus A minus, and then in which case we get h bar omega times A plus A minus plus 1/2 times psi, operating on psi, I shouldn't say times psi, operating on psi, is equal to the energy, this is a number, times psi, and this is an eigenvalue problem. And by the same token, we can write Hamiltonian operator this way: h bar omega A minus A plus minus a half operating on psi is equal to the energy times psi. Okay, so we have two eigenvalue equations, and it's not at all clear right now where this is going. This is just some interesting math that maybe seems a little bit convoluted, but this is where we'll pick up our next lecture, and we'll show how we can use these forms of the Hamiltonian to actually solve for the energy eigenvalues, okay, the eigenenergies and the eigenfunctions.